So we're going to now use this example to illustrate how to set up naive Bayes classifier. And this example is about predicting flight delays. So here is a data set that has these columns of data. Okay, scheduled departure time, carrier departure time, destination, and so on. And this data set has exactly three destinations, three departure cities and origin cities, and exactly three destination airports, origin airports and destination airports. Okay, and we are going to use not all of this data, but some of them. And here is the carrier code. Okay. So now let's look at the data itself. We're not going to use the scheduled time for departure because scheduled time is of no consequence for us. Between scheduled time and actual departure time is more important. So we're not going to use scheduled departure time. Now, and also remember, for Bayes classifiers, we need to have nominal variables. So which means if you have an interval variable, you have to convert that into a nominal variable by binning the interval variable. Okay, so you have to keep that in mind. So which means the departure time, okay, which is kind of strangely coded, so we have to do something about it. So here the digits are the last two digits are minutes, okay, and the digits preceding those two last digits are hours. Okay, so like for example, 14:55 means it is 2 hours 2:55 p.m. So which means the last two digits can go only up to 59, and after that, that's it. So it is not a regular number. So you have to recode this a little bit. So we will look at that in just a minute. Okay, and we have to bin this column, right? And then we have destination. There are only three, and we have and we are not going to use distance. Okay, we're going to use the flight day of the week. Okay, no, date we're not going to use. Okay, date doesn't matter, but day of the week and day of the month may be a factor. Okay, that could influence whether the flight gets delayed or not. The distance is really not a factor because for a flight, doesn't matter what happens at the origin, what happens at the destination is more important than the distance itself. So we are not going to use distance. Okay, and then the tail number is not useful, so we won't use that. And then of course flight status is our target. It's on time or not on time. Okay, so the first thing we have to do is to bin the departure time, and we want to bin this from suppose we want to do it hourly, right? 0 to 1 a.m. Okay, and 1 a.m. to 2 a.m. and so on. It so happens that the first 12 a.m. to 1 a.m. there are not very many observations. The real activity starts at 6 a.m. So what we're going to do is we're going to have 6 a.m. and before that, or before 6 a.m. and then after that we will go in ranges of 1 hour. Okay, so we need to first convert the departure time into the bins of before 6 a.m., 6 to 7 a.m., 7 to 8 a.m. and so on, right? So And we could probably do this in several different ways. We can use whatever method is most convenient and most efficient. And here is how I did it. Okay. So lookup table. So I prepared a lookup table, and I'm going to use this departure time to look up for the bin value. Okay. So here it doesn't really matter the absence of 60 to 99. It doesn't matter because it's just not there. All we have to do is to go from the lower limit. Okay, so that is 0, and then we do 600. So now that will be 0 all the way through 599 or 559, right? And then we will increase this by 100. Now this will be 600 through 659. After 659 there is nothing, then it is 700, right? So we will go all the way till 2100. Okay. Okay, so now we're going to set up the bin, and we would like to set up the bin value in such a way that that it's easily understandable, right? We want like 0 through 559. You don't want 0 through 600, 600 to 700. That doesn't, that is not quite readable. So what we're going to do is we're going to do this. Okay. So the way this has to be is we have to have like 0, 0 through. We want this to be like this. Um, 559. 0559. We want the lookup value to be like that, and then the next one to be 0600 through 0700. Okay, so like that. Now instead of typing those one by one like that, it will be nice if we can make it have a formula. So which is what I'm going to do. I'm going to type, to include the 0 you have to start with a quotation mark.
Would it be 659?
Would it be what?
Would it be 659, not 7?
Yeah, that's right. Yeah, it should be 650. Okay, you're right. But we'll make sure that that's what happens. Okay, so it should be like that. Yeah, you're right. Okay, so let's first get these numbers entered. Okay. So then we can use the concatenate function. Okay. So here the function will be, okay, so we want that. Okay, and then we want 0, 0. So AJ6 comma colon 0, 0, and then space and a hyphen, and another space and close quote. So this will take 06 and add that string to 06, right? And then again we take AJ6 and add colon 59. Okay. So concatenate will take information and put it all together into a string like that. Okay, so now we have the first one is we may want to change the first one to 7, just the first one alone. No, it's not AJ7 minus 1. We want 559. Or when I do that, then it becomes, okay, that's fine. Okay? So this is the lookup value, and for each of the lookup value, this will be the bin value. Now we can set up the bin. So that will be V lookup. Okay. The actual departure time, comma, the lookup table, which is that. Of course, we want to absolute reference this, and the bin text comes from this second column. So now we copy that. So now we have binned the departure time data into these 15 bins. How many bins are here? $17 bins. Okay, so equal sized bins except for the first one. First one is not the same size as all the others. So the first and the last bins we can change to 00 through 0559. Okay. And the last one is 21 through 23.